I'm Jennifer Cook, and today I got a question for you. And the question is, what would happen if we pour some different liquids into a glass? So I want to know if you think that they will mix together or if they won't mix together. So let's try it. So I have this water, and I'm going to pour it into a glass, and I think I'm going to add some blue food coloring so you can see it a little better. So a couple drops of food coloring. Let's pour the water into the glass. So obviously the food coloring mixed with the water. So my next question is, what do you think would happen if I pour this vegetable oil into the glass? So let's see. Pouring the oil in. Let me add a little bit more. So, looks like what happened was that the oil went down into the water, but then it kind of rose up to the top. So, I think we all know that some objects float on water, but it looks to me like the oil, the liquid oil, is also floating on top of the water. That's what you might call a phenomenon. A phenomenon is something that we can observe that kind of makes us go, it's not easy to explain. So, our phenomenon today is, why does oil float on top of water? And I got another liquid here. This is rubbing alcohol. Sometimes we use it to sterilize some cuts if we have a cut, or you might see it at the doctor's office before they give you a shot. They often wipe your arm with rubbing alcohol. So I have some rubbing alcohol here. Put some green food coloring into it so that we can see it a little better. So it looks like the food coloring is mixing in with the alcohol. So let's see what happens if we pour rubbing alcohol on top. So let's see if it mixes, or if it floats, or if it sinks. So you can see the rubbing alcohol floats on top of the oil. So there's another phenomenon, that even the rubbing alcohol doesn't mix with the water. It is floating on top of the oil. So the reason that happens, the explanation is about density. So density is how tightly packed matter is into a given amount of space. So the issue at hand here is that water has a higher density. It has its particles more tightly packed. Because of this, gravity is pulling on it harder, so it goes to the bottom. It gets pulled down more by gravity. The oil has particles that are not as tightly packed together as the waters, and so gravity's not pulling on it quite as much, and so it floats on top of the water. The same way a piece of styrofoam would float on top of the swimming pool. And then we've got the rubbing alcohol, and it has the least amount of density. Its particles are not packed as tight as the oil or the water, and so it floats to the top. So you can see over here, I've drawn out the particles and what they look like. So if you look down here, water, this water particle, it's just made of one oxygen and two hydrogens, H2O. So its particles are kind of small, and it can fit them pretty tightly together. They're pretty easy to pack tightly together. Look at the vegetable oil particle. It's huge. It's got lots of carbons, lots of hydrogens, a couple oxygens. You can imagine that these guys probably don't fit together as tightly as these guys do. So even though you might have the same amount of particles, they don't fit as tightly together, and so they have space between them, and that means that they're less dense. They can't fit as tightly together. Then look up here at the rubbing alcohol one. It's not as small as the water. It's not as long as the vegetable oil, but for some reason these particles also don't fit as tightly together as these do. So it has the least amount of density. So that explains our phenomenon. Why do oil and rubbing alcohol float on top of water? This is your science moment from Miss Cook.